Fine. This is meant to be a talk about performance and interactivity improvements in Collabora Online. This will include things that I am quite familiar with, server-side improvements, writer stuff, this kind of things. But it also includes client-side things, which is mostly work done by Chris, and also it includes work from Kela. So it's a real teamwork to try to do improvements around performance at all levels, so that at the end you get some coherent product where each and every piece is meant to be performing well. So first on the server side, one feedback we get from time to time is that there is this thinking that in case we render everything on the server side, then perhaps the root of all performance problems is that you do some action on the document that has to travel as an event to the server. There we do the action and it has to travel back to the client, which takes time, so the product has to be slow. And it turns out this is not the bottleneck. And in terms of numbers, you can see some durations of various things in life, how long they take. And what we really care about here, in case you want to examine if like this remote rendering is the root of all problem or not, is how much time does it take to have a packet traveling from your browser, let's say from Frankfurt to London. And it's around 27 milliseconds, something like that. And if you look at what's the latency of your Bluetooth keyboard, that's already longer than that. If you take into account how much time it takes to actually type those keys as you are typing, depending on how good or bad typist you are, and when you are thinking about what to actually type, all these things are require way more time compared to the network latency. So when we started to profile things, it turned out that there are things that we can still improve and not run into any kind of problem around the network latency. So that's probably good news, because what has to be improved, the parts that have to be improved, are things which are easier to improve compared to speeding up network latency. So there is a group of 3 concrete improvements that we did in 2504 in writer and in all components on the server side. One concrete improvement is that on writer, in case you have a large document with many pages, then whenever you change the document, we need to update the layout. You type enough characters, which means you need to move that word to the next line or to the next page or something like this. And it turns out that it pays off a lot to do a quick synchronous layout just for the visible part of the document, and then do an asynchronous, slower layout for the parts which are not visible. So, for example, in case you added a few new paragraphs at the start of a long document, then at some point that will increase the page count. But what you are primarily interested in is that you press a key and you want to instantly, almost instantly, see a result. And that part is doable in case we prioritize the visible area of your document. So this is what we measured here. You can see a flame graph here about like where the time is spent. These flame graphs are a very effective way of communicating what is the performance problem. What you see there is that the width is of this chart is proportional time. So in case something is wider, then that's bigger performance problem. In case it's smaller, then it takes less time. And also you have this stack of various items here. So that's in the software source code is the various functions. So in case you find something which is unexpected for that action, the lower it is and the more probable that you can eliminate that, the bigger impact it will have. In case you find something at the top, it should not happen for that action. It's still good to optimize the TOI, but you will have a larger impact in case you optimize something at the bottom. And the actual color of these cells are not that interesting. That's just to make it easier to differentiate between the lines. So that was one improvement for interactive editing. Prioritize the visible area and do the rest in an async layout. The other use case we have is in case you have a large document and you want to load that, then we can load the document and only lay out just the visible part, like that's typically the first few tiles, the first page of the document. We can do that separately compared to the rest of the document. And that also gives you some nice speed up. Especially for documents with multiple hundreds of pages, this makes a big difference. Now, something that is useful for other components as well, not just Writer, it's also helpful for Calc, Draw, and Impress, is an optimization on invalidations. The LibreOffice core code base is using invalidations quite liberally. The thinking was that when this was not triggering some network traffic, but it was working offline on the desktop, then it was relatively cheap to invalidate something. Also, if you invalidate a big, large area, then you are on the safe side. What the tiny bit that needs repainting will be definitely repainted. So that's still better compared to overdoing the optimization, not invalidating something, and then invalid content is visible on the screen. That's a larger problem. That was the thinking several decades ago. Now, with online, it actually does matter how much you invalidate, because invalidations cause network traffic, and that adds latency, and we are much more sensitive to that. So what we do is we track the areas that we already painted, and in case the code would try to invalidate an area which was not painted, then we can optimize these invalidations away. And that helps a lot if you count. Thank you. If you count the amount of invalidation protocol messages on a document load, ideally this would be close to 0 because you did not change anything yet. So it should be a small number. And for, again, a larger document of multiple hundreds of pages, this was in the range of hundreds, and now it's less than 10. So that was a good improvement, I guess. Now, specifically for Calc, there was some work from Kelon on profiling how this threaded formula compilation is working in Calc. And it turns out that we had some initial workload with some well-known, quite frequently used benchmark documents where it was working nicely, but then later some correctness problem was discovered, so logs and correctness fixes were added later, which is fine because first we want to be correct and then we want to be fast. But it turned out that there was this shared number formatting which turns your integers to some string that can be painted on the screen. And it turns out that that was a big slowdown, to the extent that actually trying to thread something slowed down the entire process. So that kind of kills the whole idea around threading. So with a series of changes from Kelon, we now have quite a good story there. It actually makes sense to thread like large spreadsheets because it is noticeably faster that way. The last server-side part I would like to point out here is that we have something called watchdog profiling, which means that we have a main loop on the server side which kind of have jobs. So one document is one Git process, and that has a main loop, and that has jobs to be processed on the main loop. And we should have many small jobs there, so that in case we want to interrupt something or we want to prioritize things, then we can do that. That also means that in case there is one job which is quite long, then that will be a problem. In case multiple users are typing, then we want to make sure that we can switch between these users with many small jobs, not few and large jobs. So we have a watchdog which can signal us in case any job is taking more than 100 milliseconds. We call this stalls. And then we needed to find some rare syscall to hook into the profiler, and that gives you a flame graph of these stalls. And even with long-term profiling, it can be combined, and you can see where we have these hanging parts. So we could do a number of improvements based on this data. Moving on to client-side rendering, like client-side improvements, we can also have a watchdog on the client side. It's somewhat similar. So on the browser, you have the browser that will do various actions for you, and the idea is that you don't have multiple threads there. You can have your window of time when the JavaScript code is running and does something, and it's important that no single job is too long, so that the browser can do its own operations when your JavaScript code is not running. So there we have a bit more tight limit. After 50 milliseconds, we will warn in debug mode that this piece of JavaScript code is doing too much work in one step. It should be split up. It should be done in increments. Also, there was lots of work from Chris on better and more intelligent type caching, so we can cache more around the visible area of the document. Also, when you scroll, then we predict that you will probably keep scrolling. If you started to read the document, you started to go down, then you probably will go down further. And then again, we can preload more and have more content in the browser already, so we can show that instantly. Something specific to Impress is the new WebGL-based slideshow, which means we don't need to generate an interactive SVG for the whole presentation. In case you had lots of slides, large resolution images, the high resolution images, then that took a bit of time. And in case with the WebGL-based slideshow, you only have to render the first slide. You can already show something, and then it's much more snappy. I mentioned this, the preloading in general, but also for the slideshow, we can preload the previous slide, next slide, and that also means that when I change slides, then it's more snappy. The last specific browser-side improvement I would like to note is something from Shimon. We have a layouting service so that we can patch these DOM touching operations together, which also helps because the browser has to do a lot of work once you've stopped touching the DOM. And in case you can group these things together, then it will be more consistent. If you scroll down in a document and you need to adjust the cursors and the commands and the ties and so on, if all these move together, then it will give you a feeling that it's more fast, it's more interactive, it's more snappy. Yeah, I guess that's it. The idea is that we try to see how performance is not just about CPU usage. It includes also interactivity and latency and memory usage and giving you this kind of perfect frames in the browser. We have demo servers where we have this long-running CPU profiling, which also gives you data. We try to also do multi-user testing. We have these weekly community calls where we have many people and interacting with the same document, and it gives you a feel of how usable, how snappy the product is before we actually release it to partners, customers. And also we can do some kind of intensive stress testing, and we can also provide that. So yeah, that's the kind of flavor of performance improvements we did in the last year. Thanks for listening.